Assalamualaikum. Assalamualaikum. Today is 25th of June 2020. We are going to have our online lecture on memory and storage, right? This is the second last lecture that we need to cover for this subject and for this semester. Then after that, we are going to go for our second test. And on the 27th, I think, that we are going to have our finals, right? Then the finals will be on asynchronous online examination, just like we did for the test 1, and also test 2 also will be the same method. Okay, so now I'm going to okay, before that, any question from the last week last lecture? If you have no question, then I will start with the lecture for tonight. Hopefully we can finish in 1 hour, and we have about 26 slides. So there is no calculation for this chapter. Just an introduction to the memory and storage, and you just need to have an understanding, that's all, right? So this is not that technical. Should be easy for you, right? And what I will do is that most probably that I will give you some assignment to do. Most probably by end of this week, I will upload all the assignments that you need to do. Okay, and I'm going to share the slides now. Okay, can you see the slides? Okay. Now we are going into lecture 10, which is equivalent to Floyd textbook, Digital Fundamental, chapter 10, memory and storage. What is a memory? Memory is actually the portion of a computer or system that stores binary data. It stores ones and zeros in the computer. So that portion of the computer which store those data, is called a memory or storage. So the memory can be permanent memory and can be temporary. Temporary means that when there is no electricity or no power, you will lose the data in that memory. And there is a permanent memory where even though there is no data and no electricity, no power, it will keep the data in the storage. So that is what we call a memory, or also sometimes we call it storage. Okay, in a computer, memory is accessed millions of times per second. Thus, the speed and accuracy is paramount. So that's why when you buy a computer, you ask, what is the speed of the computer? How many gigahertz? That is actually to indicate how fast your computer will be able to access the memory or the storage, and also to do arithmetic operation. Can do the addition, subtraction, and multiply or division. So the speed is actually indicate for that. Remember in the flip-flops that we have the clock, right? Right? So that clock is actually how fast that's the changes from ones and zeros of that side of clock will indicate the speed of the computer. So how fast that will be able to access the memory. Memory stores data in units that have from 1 to 8 bits, or even actually can go up to now is 16 or 32 bits, or 64 bits, depending. But these are the terms that you will find in the literature, in the textbook or whatever, or in the specifications of computer, that you will find words like bit. Bit is actually the smallest unit of binary data. Okay. Bit is actually a smallest unit of binary data. Then you have a byte. A byte is actually as a 8 bits, a group of 8 bits. So it's called a byte. A nibble is actually 4 bits. It's a byte split into 2. So that's called a nibble. So 2 nibble is equivalent to 1 byte. 4 bit is equivalent to 1 nibble. And another term is word. In memories, it is defined as a group of bits or bytes that act as a single entity that can be stored in the one memory location. It contains 16 bits or 2 bytes. Okay? A word is 16 bits. So that is the terms that you have to be familiar with: bit, byte, word, nibble, right? Okay, any question?
No, sir.
Okay. Basic memory array. So data stored in a memory in a form of array. Each storage element in a memory can retain either a 1 or 0, and it is called a cell. So 1 bit actually stored in a cell. And these cells are organized as an array. So each block in the memory array represents a one storage cell, and its location can be identified by specifying a row and a column. You give the row, the location of the row and location of column, then you get that particular byte and that particular bit. So this is an example. Let's say you have a 64 cell memory. A 64 cell memory you can arrange in 3 different ways. You can arrange in an 8 by 8 array. You can also arrange in 16 by 4 array or 64 by 1 array. Okay, so this is a 8 byte memory. So because this is actually 1 byte, because you have 8 bit here in a row. So this is 1 byte. This is 1 byte. So you have 8 byte. So this is a 64-bit memory or 8 byte memory. When you arrange in 8 by 8 array. If you arrange in 16 by 4 array, it's also a 64 cell memory. This is called a 16 nibble memory, where this 4 bit a nibble. So this is a 1 byte. You have first nibble and second nibble. First nibble and second nibble. You can store that way. So you have 16 rows by 4 columns. It can also be arranged in 64 by 1 array. This is 64 rows and 1 column. So each actually 1 bit. So you can store actually maybe 8 bits. The first 8 as a 1 byte, and the second 8 as a second byte, and so forth. So you can arrange in 3 different ways for the 60 cell memory. And of course, when you arrange in such a manner, you need a way to indicate where is that particular data is placed in the memory. So in order to do that, you have a term called address. Address basically the allocation of a unit of data in a memory array. In a 2-dimensional array, the address of a bit is specified by the row and column. Okay? And the address of a byte is specified only by the row. Like this. That is actually a bit, which is the blue one. So in order to locate that bit, you have to specify the row and the column. So there's a bit. So you have to give the address. So the address of that blue bit is a row 5 and column 4. So that is the address, 5, 4. And the blue row in that diagram on the right is a byte. And that is located in the row 3. So there's 1 byte. The address is in row 3. Another example, a memory address in the 3-dimensional array. So you have a row, you have a column, and you have the depth. So the address of the blue byte is row 2, column 8. If you compare with this is a 2-dimensional array. You only give the address for a byte with a row number, right? But in a 3-dimensional array, you give the address with row and column, because the depth of 8 bit is the data in the 3-dimensional array. Okay. The address depends on how the memory is organized into units of data. So it depends on how you design the memory chips. So the designer basically decide how the addressing convention is to be used in order to access that particular memory location. Okay. Memory and storage also has a capacity. Capacity is basically the total number of data units that can be stored. For example, in your hard disk, you have 1 terabyte. What does it mean 1 terabyte? Basically that in that particular hard disk, you can store data of 1 terabyte. So 1 terabyte you multiply by 8, then you get 1 terabit. It's more than that. So 8 terabits, because 1 terabyte is equivalent to 8 terabits, because 1 byte is 8 bits. And you want to indicate whether, you want to know whether it is byte or bit, you look at the letter B. If it's a capital B, it means it's bytes. If a small b is a bit. So computer memory typically has about 256 megabyte or more of internal memory. So minimum now is about 256 meg, maybe even more than that now. For example, for this one, you have 8 by 8, which the total capacity is 64 bits. Yes? Okay. These are the basic operations, memory operations. Of course, the obvious one is that the addressing operation, because you need to know where the data is located. So the addressing operation. Another one is that because you want to use the memory as storage, therefore you need to be able to write to that memory. And second, you need to read the data from that storage in order for you to use. You are not just going to store the data and forget about it, because you store because you have the intention to use that data later. So you have to be able to read that data out of the memory. So the basic memory operations, you have these three: write, read, and addressing. What does it mean by write? Write means that you put data into a specific address in the memory. When you save your Microsoft Word document, for example, basically that you are writing the data into the memory. What does it mean by read? Read basically copying data out of a specific addresses in the memory where needed. When you want to edit that Microsoft Word file, for example, then basically you read from that memory and you put it into the temporary memory in your computer. Then you do the editing. Okay? You do the editing basically that you do in the temporary memory. You are not editing in the storage where you store previously. When you want to save, when you hit save, then the data that is in the temporary memory is being transferred into the storage and being saved there. Okay? Then the addressing is basically that the part of both the read and write operation that you have to select the specific memory address where to store, and when we want to read, where to read. And that actually is transparent to you because the application actually do that for you on your behalf. Okay? If you are working as a computer engineer, that is a different story altogether. That you have to, when I did my bachelor degree, that I have to basically design the operating systems where I have to basically write codes how to do the addressing, where to write a certain data to a certain location, right? But you as a user of a computer, you don't need to know that. But within that application, it has this addressing operations in order to read and write the data to the storage. Okay. Then you have the address bus. When you want to write something or when you want to access something, that you have to indicate to the memory, okay, which location. So this actually being done through a address bus. Address bus is a set of lines or wires used to identify a particular location in the main memory. In other words, the information used to describe the memory location travels along the address bus. So for example, let's say you want to address a location of row 5 here. So maybe you send in the address bus is 101. 101 in binary is equivalent to 5 in decimal. So you send 101 on the address bus, then the address decoder will pick it up, that 101, and translate into, okay, which row is basically that 101. So it's a row 5. So 0, 1, 2, 3, 4, and 5. So you have at row 5. So that is how the addressing is done. And this address bus is a one-way street. It's not a two-way. It's only going in to the address decoder. So that is the address bus. Another bus is the data bus. Data bus is actually a set of lines or wires through which the data is transmitted from one part of a computer to another. So data bus, the function is that to take the data from the memory out to another part of the computer, or to take in the memory from another part of the computer into the memory. So therefore, the data bus is a bidirectional, which means that the data can go either directions, into the memory during the write operation and out of the memory during the read operation. When you do a write operation into the memory, the data, the previous data in that particular location in the memory will be overwritten. Whereas when you read the data out from the memory, you only take a copy of what's in the memory. You don't destroy the data in the memory. You don't erase it. But you just take a copy and put into a data bus and send back to the part of the computer which requests for that data. So that is the data bus. Okay. Any question? No.
No, sir.
Very easy, right? Okay, now we go into the how write operation is being done. Very simple. Let's say you want to write, let's say you want to write something. Let's say you want to write this data 10001101 into a location indicated by the address register of 101. So first, a code in the address register 101 sent to the address decoder. What the address decoder will do is that to decode 101 into the location based on row or columns. So in this case, the address decoder decodes the address so the address decoder will decode 101 as 5. So this line will go high. The rest are 0. So this line will go high. So the address decoder decodes the address and select the specified location in the memory. So basically this line will go high. Then the memory gets a write command. This write command, basically this line is high. So you get the write command. So the data in the data register is sent to the data bus, okay? From the data register is sent through the data bus to the selected memory address here. So 1001101 here, 1001101. Then, since this is high, the right line is high, therefore the data 10001101 is written at this address 5. And the previous data here gone, replaced by this data. So that is how the write operation is being done. So that is how you write into your hard disk, for example, or into your USB storage, your thumb drive, right? Basically, that is how the write operation are being done. Any question on the write operation? If not, I'm going to go into the read operation.
No, sir.
Okay. Wait. Okay. Read operation. Read operation is the opposite of the write operation. But the process still starts with the addressing, with the address register. Let's say in the address register, you have 011. And this code 011 is placed on the address bus and sent to the address decoder. So the address decoder will decode 011 as row 3. So row 3 is high. The rest are low. Then the read line is high to indicate that it is a read operation. So what happened is that the data from the row 3, okay, is placed on the data bus and sent to the data register. So 11000001 being copied or written into the data register 11000001. And the data in the memory is not destroyed. It's still there. It's only copied into the data register. So the content of the address tree is placed on the data bus and shifted into the data register. The data unit remains stored and is not erased by the read operation. So that is the read operation. So you have Basically that when you are doing read or write operation, you have the addressing part of it, involve the address bus, involve the decoding of the address, then involve the memory, involve the data register and data bus. Same thing with the read, but it's the other way around. Still you need the address register, address bus, but the data for read, the data is basically that from the memory goes into the data register. For the write is from the data register, goes into the memory. Okay, any question? If not, I'm going to continue. So, in terms of memory, you have two types. Two major types. So RAM and ROM. For the internal memory, if you go and you want to buy the computer, the notebook, whatever that you ask for, what is the RAM size? Betul tak? 64K, 256, 256 meg, whatever.
Betul, sir.
So that is actually the RAM. It's random access memory. So random access memory, basically that all addresses are accessible in equal amount of time and can be selected in any order for read or write operation. It has both read and write capability, and it is a volatile memories. What it means is that when there is no power, the data is lost. So that's why whatever is in the RAM, let's say your power trip blackout and you don't have the power backup or your battery is dead, for example, in your notebook, therefore the data is all gone. Because it's a volatile memories. That is RAM. Another one is ROM. It's the read-only memory. This is a type of memory where data can be stored permanently or semi-permanently or semi-permanently. Data can be read from a ROM but not write. ROM is a read-only memory. Basically, that you store once, then you just read from it. So normally, what you have actually in your notebook or your computer, you have your operating systems is normally is in a ROM. So when you boot up the computer, okay, when you switch on the computer, then basically that your operating system or your boot sector is actually in a ROM. So that one will kickstart. You start your computer. So it's a non-volatile memory. Basically that it retains stored data even if power is turned off. Okay. These are the
Macam
types
pernah
of
dengar.
RAM. Huh?
Macam pernah dengar volatile dengan non-volatile. Oh, pernah dengar sir masa asasi.
Then the non-volatile is basically is a ROM. Non-volatile memory. It's a ROM, read-only memory. Okay. Now we are going into the random access memory, RAM, the types of, okay. These are the major categories of RAM. They are static RAM, SRAM, and dynamic RAM, DRAM. So for your notebook, for example, that your internal storage can be either static RAM or DRAM. And SRAM, you have asynchronous RAM, SRAM, and synchronous SRAM with burst feature. For dynamic RAM, you have fast page mode DRAM you have extended data out DRAM, you have burst EDO DRAM, and synchronous DRAM. So these are the types of DRAM. The types of RAM. So you have RAM divided into two, which is static and dynamic. Static is asynchronous and synchronous. Whereas DRAM, you have the fast mode DRAM, you have extended data out, you have burst EDO, you have synchronous. So this one you can find data on your own. Right? I'm just introduce you. So this is the characteristic of the SRAM and DRAM. For the storage element, SRAM use latches that we learned 2 lectures ago. It can store data as long as DC power is applied. As long as there is power, it can store data. When there is no power, gone. Data is gone. Whereas DRAM use the capacitor. It cannot retain data very long. So capacitor must be recharged. So you have the refreshing process. Remember in this last semester, when we learned about charging and discharging of the capacitor, so this is one of the usage. Basically that you charge the capacitor for you to store the data. So the read operation, data can be read much faster in SRAM. DRAM is slower than SRAM. For the capacity, SRAM store less data, whereas DRAM store more data. This is actually given on the physical size, compare in terms of the physical size and cost. So SRAM is basically that more expensive and bigger size. DRAM is basically that smaller size and less cost for the same amount of data storage. The implementation for a given physical size and cost, cell is more complicated for SRAM. Less cells can be crammed in a given chip area. Whereas for DRAM, cell is much simpler and more cells can be crammed into a given chip area. So basically that DRAM is more compact. It's smaller. So if you look at the DRAM or SRAM, it will give you the what do you call it? Will give you this different size if you look at the physical memory. Okay? Both SRAM and DRAM will lose data, stored data when the DC power is removed. So it's a volatile memories because it's a RAM. Okay. Any question? So this is a SRAM. It uses latch memory cell. You remember this? This part?
Latch.
This is a D, right? D latch. Right? From last lecture. So this is data in. And you have a select line. So this is actually a D. So D bar. Remember? So this is what we learned last 2 lectures ago. The latches. It is not a flip-flop because there is no clock. So it's a latch. As long as DC power is applied to a static cell memory, it can retain 1 or 0 indefinitely. If power removed, the stored data bit is lost. the cell is selected by an active level on the select line. So this is actually, remember the enable line, EN in the latch. EN line here. EN. Okay, this is the EN line, enable line, which is the select, we call a select here, and a data line. This is a D. So it's either 1 or 0. This. So when the select line is high, then D will be written. So this one, let's say select is, this is really this one because you have this one, this bubble here. Basically that select is 0. Select is 0. Then this is, okay, select is 1. Let's say data is 1, so it becomes 0. So 0 and 1. So this one will be written here as 1. The data bit 1 or 0 is written into the cell by placing it on the data line. The data bit is read by taking it off the data outline. So basically that this, whatever data here, the value of here will be written to the memory. This basically will be written. So that is the static RAM. And this is actually here. In this cell here, actually you have this secretary. This secretary is in this cell. Okay, for each cell. So imagine if we have one terabyte, meaning that 8 terabits. So you have 8 terabits of this.
Banyak tu.
Yes. What you are learning is actually only you learn at one cell of that memory. So that is what we are learning now. We are learning only the behavior of that one cell and duplicate that 8 tera times.
Banyak tu.
So the memory cells are organized in rows and columns, and it's being put in row and column. All cells in a row share the same row select line. Single data line is used to serve as both an input data and output data. So we call it data I/O through the data input and data output buffer here. So this is how the static RAMs looks like, being structured. Okay, you just need to know lah.
Baik, sir.
Now this is dynamic RAM. Store a data bit as a charge in a small capacitor rather than in a latch. So in here, it's actually a capacitor. Okay, DRAMs is simple and cost-effective, but require fresh circuitry to prevent loss of data. So we have to have additional circuitry so that the memory, the data here will not lose. Okay. To refresh requires additional memory circuitry and complicates the operation of DRAM. DRAM use a technical addressing multiplexing to reduce the number of address lines. So this address line, so you have a multiplexing So I'm not going to go to detail. Just at least you know the difference. Okay. So that is dynamic RAM. Another memory was remember the read-only memory, the ROM. ROM contains permanently or semi-permanently stored data. It can be read from the memory, but either cannot be changed at all or cannot be changed without specialized equipment. So ROM, if it's a semi-permanent stored data, basically you can change. But in order to change that data, you need a specialized equipment. Maybe you need a UV light to erase before you can write. And there are ROM, which is actually you can write once, then you cannot change anymore. If you want to change, you have to throw it away and put a new ROM. It stores data that are used repeatedly in system applications such as tables, conversion, or programs instruction. ROMs are non-volatile memories, retain stored data when the power is off. So this is the type, the ROM family. You have mask ROM, you have PROM, which is programmable ROM, you have EEPROM, which is erasable PROM, you have UV-EEPROM, which is ultraviolet EEPROM, and you have EEPROM, electrically erasable, and you have flash. Remember the flash cards? So you have that flash ROM. What is a mask ROM? Usually we only refer to ROM for the mask ROM. This is the basic one. It is permanently programmed during the manufacturing process to provide widely used standard functions. The software mask is burnt into the chip. Basically, it's burnt into here. So this is an example of the ROM IC, ROM chip. So burnt into this, once the memory is programmed, it cannot be changed. Normally used in network operating system and server operating systems. That is a mask ROM. PROM, programmable ROM, is developed in 1970s by Texas Instruments. It is made as a blank memory. So this is an example of PROM here. A type in which data are electrically stored by the user with the aid of specialized equipment. So we have a PROM programmer that you have to put this into a programmer, then you download the program into the programmer, then the programmer will burn into the chip. Uses the same type of fusing process to store bits in which memory links is burnt, open, or left intact to represent ones or zeros. The fusing process is irreversible. When it's burnt, basically you cut off the link. Then you cannot reconnect. So once a PROM is programmed, it cannot change. It's a one-time programmable only. So you cannot erase. The third type is EEPROM. It's erasable PROM. It's a metal oxide device, metal oxide silicon device. It is developed to address the weakness in PROM. Therefore, EEPROM can be written more than once. So it's like this, something like this. So erasable PROM is an upgrade of the PROM. PROM you can write once and you cannot change. Whereas EEPROM, you can change the program inside there. So but in order to change the existing program, you have to erase it first. You erase whatever in there, then you write a new one. So one type of EEPROM is called ultraviolet EEPROM. So electrically programmable by the user, but the stored data must be erased by exposure to UV light over a period of several minutes. You can recognize the UV EEPROM is this. It has the transparent window on the IC. That is where you expose the IC inside. Actually, this is really the real IC, the real semiconductor, even though this is the size. This is the size of the IC, but the real semiconductor is this, the one, the small square inside there. So this opening, the circular opening here, is made of glass that is to allow the UV light to erase whatever in the semicon here. Okay. When you erase, then you can write a new data there. So this is the called ultraviolet EEPROM. And the next one is the electrically erasable PROM. So instead of using the ultraviolet light to erase, this one erase using the electrical signal. So this one you don't see any more window, glass window for the UV light to erase data. This one you can erase through the electrical signal. So can be erased in a few milliseconds and programmed with electrical pulses. If UV, it requires a few minutes. To erase this, a few minutes. But this one, electrically erasable, you only require milliseconds. Then after that, you can reprogram. So since it can be both electrically written into and electrically erased, the EEPROM can be rapidly programmed and erased in circuit for reprogramming. So basically that you don't have to take this out from your circuits. Like this one, you have to take out this. You have, let's say you put this here, right? Then in order, if you want to change the program, you have to take this out, put in the UV, equipment to erase. Then you take this into the program equipment, you program, then you put it back here. Whereas for the electrically erasable PROM, you don't have to. You can write a program actually to erase electrically and to write electrically on the same board. So the erase in circuit for the reprogramming. So you don't have to take this out and do whatever, because you can do it in circuit. Another one is flash ROM. Recognize this? This? Recognize this? Looks like your, what? In your handphones? Your memory card. Yes, so there's a flash ROM. Updated version of EEPROM. It was invented by Toshiba and got its name from its capability of deleting a block of data in a flash. Flash memory provides this advantage over the EEPROM by enabling these features of altering many locations simultaneously. So this is EEPROM, flash ROM. This also flash ROM. This also flash ROM. This is an example of flash ROMs. This is how the internal of a simple ROM. So basically that the blue, this blue one is stored 1, and the gray one here is stored 0. So here, okay, basic read operation. Let's say you want to read from the ROM. When a binary address code is applied to this address input line here, the corresponding row line is goes high. So maybe, for example, this one is goes high. Okay. This high is connected to the column line. So it's connected to the whatever line, column line, through the transistor at the junction. This is through this, this transistor here. So here, you see this? When it's 1, basically this is connected. So when this is high, therefore this is high. But for the one that is zeros, see, this is not connected. So this is 0. Okay. So the high is connected to the column line through the transistors at the end junction where a 1 is stored. So this basically, for example, this one, okay, this is connected to here. This here, see this? But this one is not. This line is not connected to this. This transistor is off, so it's 0. At each cell where a 0 is stored, the column line stays low because of the terminating resistor. The column lines form the data output. The 8 data bits stored in the selected row appears on the output line. So it's appear here. The data is appeared here. This data output line. Okay. So that is how a simple ROM operates. That's all. Any question? So you can go through the slides, and then after that I load the recording on the what we call it on YouTube. Then you can relook on the video. Right? So this is a very easy chapter. Just basic information overview for you to understand, because if I go through the details, there are a lot of details actually, but it's not required for you, because it will be the subject will be very heavy. So I just give you the basic overview so that you understand. Any question?
No, sir.
No question. So
No, sir. No, sir.
so I stop sharing. Okay. So maybe next week I just finish this on the microcontroller. That one I think maybe in half an hour I can cover. So we have another half an hour of lecture, which is equivalent to about 3 hours of a normal face-to-face lecture. Because when face-to-face, you ask a lot of questions, right? So because just this online lecture is basically that because you don't ask question and whatnot, so I can go very fast. So 1 hour of online lecture is equivalent to about 3 hours of the normal lecture actually. So any question?
So
If not, I'm going.
sir.
No, if not, I'm going to stop the recording, and I want to go downstairs and take the example of the memory card to show you. Okay.
All right, sir. Okay, sir.
So I'll stop the recording and give me about 2-3 minutes to go downstairs, and after that I'll show you. Okay.
Okay, sir.
So
Yes, sir.
I stop the
Sir.
recording now.
Saya record lah.